Hello everyone. Welcome to today's presentation. I am excited to share with you a summary of atoms and molecules for Class 9 CBSE. In this session, we will explore the fundamental concepts of atoms and molecules, their structure, and their importance in chemistry. So let's get started and dive into this fascinating topic. Let's take a closer look at the historical background of atomic theory. Indian philosophers like Maharishi Kanad proposed the idea of Parmanu, which means indivisible particles. Similarly, Pakadha Katayama believed that particles exist in combined forms, which is quite interesting. Moving to Greek philosophy, Democritus and Leucippus introduced the concept of atoms, which are also considered indivisible. These early ideas laid the foundation for modern atomic theory. Fast forward to the 18th century, scientists like Lavoisier and Proust made significant contributions by establishing the laws of chemical combination. These laws help us understand how elements combine to form compounds. For example, the law of conservation of mass tells us that mass is neither created nor destroyed during a chemical reaction, which is fundamental to chemistry. Then there's the law of constant proportions, which states that a compound always contains elements in fixed ratios by mass. For instance, in water, the ratio of hydrogen to oxygen is always 1:8 by mass. These principles are crucial because they help us understand how atoms and molecules behave during chemical reactions, connecting the dots to the overall understanding of matter at a microscopic level. Let's talk about Dalton's atomic theory, which is fundamental to understanding matter. First, it states that matter is made up of tiny, indivisible particles called atoms. These atoms are the basic building blocks of everything around us. Now, atoms of the same element are identical in both mass and properties, which means if you have two atoms of hydrogen, they are exactly the same. On the other hand, atoms of different elements have different masses and properties, which is why, for example, hydrogen and oxygen are so different from each other. Dalton also explained that atoms combine in small whole number ratios to form compounds. This is a key concept because it helps us understand how different substances are formed. It also explains why the conservation of mass holds true in chemical reactions and why compounds have definite proportions of their elements. In essence, atoms and molecules are the tiny particles that make up everything. And understanding how they combine helps us grasp the fundamental nature of matter and the chemical reactions we observe all around us. Now, let's look at what we have on this slide about Class 9, CBSE atoms and molecules. First, atoms are the fundamental building blocks of matter. They are incredibly small, with atomic radii measured in nanometers, which means they're a billionth of a meter. Modern symbols for atoms are standardized by the IUPAC, the International Union of Pure and Applied Chemistry, to ensure consistency across scientific communication. When we talk about atomic mass, we use the atomic mass unit, or U, which is defined as 1/12 the mass of a carbon-12 atom. This helps us compare the masses of different atoms relative to a common standard, and we often use these relative atomic masses for calculations. Moving on to molecules, these are the smallest particles of elements or compounds that can exist independently. For example, molecules of elements can be monoatomic, like helium or argon, which are single atoms. They can also be diatomic, like oxygen, hydrogen, nitrogen, or chlorine molecules, which consist of two atoms. And some are polyatomic, like phosphorus molecules, P4, or sulfur rings, S8, made up of multiple atoms bonded together. When it comes to compounds, molecules are formed by atoms of different elements coming together in fixed ratios. For example, water H2O, ammonia NH3, and carbon dioxide, CO2, all have specific ratios of atoms that define their structure and properties. So, understanding atoms and molecules helps us grasp the basic structure of matter, how everything around us is built, and how these tiny particles combine to form the substances we see every day. Let's take a closer look at the concept of ions. Ions are charged particles, which means they have either gained or lost electrons. When they carry a positive charge, we call them cations, and when they have a negative charge, they are anions. Now, there are also polyatomic ions, which are groups of atoms that together have a net charge. For example, ammonium, NH4+, and sulfate, so too are common polyatomic ions. When we write chemical formulae, we base them on the valency or combining capacity of the elements involved. The key rule here is that the total positive charge must balance the total negative charge, so the compound is neutral overall. Also, when writing formulas, we always put the metal first, followed by the nonmetal. And if there are more than one polyatomic ion in the compound, we enclose it in brackets and add a subscript outside to show how many are present. For example, we have NaCl, which is simple sodium chloride, or MgCl2, magnesium chloride, where the two chloride ions balance the magnesium. In aluminum oxide, Al2O3, the two aluminum ions balance the three oxide ions. And for compounds like calcium hydroxide, Ca(O2), the brackets show that two hydroxide ions are attached to one calcium ion. Lastly, in ammonium sulfate, NH4+2SO4, the brackets indicate two ammonium ions combined with a sulfate ion. Understanding these basics helps us grasp how atoms and molecules come together to form compounds, which is fundamental to studying chemistry. Now, moving on to slide 6, which focuses on Class 9 CBSE concepts related to molecular and formula unit mass. First, let's understand what molecular mass is. It's basically the sum of the atomic masses of all the atoms in a molecule. For example, in water, H2O, the molecular mass is 18 atomic mass units, or 18U. This helps us understand how much a single molecule weighs. Next, we have the concept of formula unit mass, which applies to ionic compounds. For instance, in sodium chloride, NaCl, the formula unit mass is about 58.5 U. This is the sum of the atomic masses of sodium and chlorine in their simplest ratio. Now, why are these calculations important? Well, they are fundamental to quantitative chemistry. Knowing the molecular or formula unit mass allows us to calculate how much of a substance we need for a reaction, or how much product we can expect. Let's also remember the key takeaways. Matter is made up of atoms and molecules. The laws of chemical combination, such as conservation of mass, form the basis of atomic theory. Chemical formulae give us a clear picture of what elements compose a compound and in what ratio. And finally, calculating these masses accurately is essential for practical applications in chemistry. All these points connect to our overall understanding of atomic and molecular structure, helping us grasp how substances are built and how they interact. Now, let's talk about the core of our services, providing academic tutorial support across a wide range of student levels. We cater to primary classes, intermediate, and even senior secondary classes, specifically aligned with the CBSE board and other relevant examination boards in India. Whether it's through offline classes or online sessions, our goal is to ensure accessible and effective learning for all students. We understand that each student's learning journey is unique, which is why our Class Cloud platform is designed to elevate that experience. It's not just about accessing material, it's about transforming how students learn, making it more engaging and personalized. Our overarching aim is to support students at every stage, helping them excel in their exams and build a strong foundation for their future. This service embodies our commitment to making quality education flexible and accessible, no matter where students are located. So, as we've seen throughout this presentation, leveraging technology and tailored support can truly elevate the learning journey, and that's what Class Cloud is all about.